Okay, page 100. We have the key concept on the top. Two quantities x and y have a proportional relationship if all the radius y over x for related pairs of x and y are equivalent. A proportion is an equation that states that two radius are equivalent. Remember yesterday when we talked about the proportional relationships, when the radius were equivalent between them, right? We simplified and we found that the radius were equivalent, so we had a proportional relationship, and we can use this proportional relationship to find the value of one variable, okay? And you have the one example in here, 3 over 120 equal 5 over 200. And you have a little chart at the right part to represent the same again. You have the value for the x, and you have the value for the y. X is 120, later x is 200, y is 3, and y is 5 for the second proportion, okay? Or relation in this case. Y over x is only the division. You are going to find the division. You divide 3 over 120. Remember we did yesterday this because we need the fraction and later simplify the fraction to compare with the other numbers you have, okay? So in the part that says, do you understand? The first question you have, this is the theoretical part. You have the question number 1. How are proportional quantities described by equivalent radius? Proportional quantities, okay, remember they are proportional and are related if the radius are the same. If the radius are equivalent, so we are going to have a proportional relationship. Number 2, look for relationships. How do you know if a relationship between two quantities is not proportional? When is not proportional? When you have the two quantities and they are not equivalent. When the fractions you have are not equivalent, or the quantities you have are not equivalent. Number 3 is reasoning. If the radio y over x is the same for all related pairs of x and y, what does that mean about the relationship between x and y?
Mister, can you repeat the last one, please?
Number 2, the fractions or the quantities you have are not equivalent because they are not proportional. The question says that they are not proportional, so the fractions are not equivalent. Or the radius are not equivalent if you want to use the word radius. Okay, number 3. If the radio y over x is the same for all related pairs of x and y, what does that mean about the relationship between x and y? They are going to be equivalent. If they are the same for each pair of x and y, they are going to be equivalent. Number 4, do you know how? In this part, we need to do it practically. Use the table below. Do x and y have a proportional relationship? And explain. X and y with a proportional relationship, we can divide. Do x and y have a proportional relationship, guys? If we divide, for example, you can divide y over x, or you can use x over y. The important part is that you use the same for all the numbers to divide. In this case, for example, you divide y over x. I'm going to write it on the board, and I'm going to ask you if it's equivalent or not. Five over 2, it's equal 7.5 over 3 is equal 12.5 over 5 equal 18 over 8. If you simplify this, are the same quantities.
No.
It's going to be proportional, a proportional relationship.
No.
No, this is different from this one. You can prove it divided. You divide 5 by 2, you have 2.5. You divide this one, 7.5 by 3. I'm going to prove it, guys. 2.5. I'm going to divide the other one. 12.5 by 5. I have 2.5. And the other one, if I divide 18 by 8, 18 by 8 is 2.25. This is different. The last one is different. So they are proportional relationship until here. So in this part, I have this is equal to this, and this is equal to this one. But when I, since this part, they are different. So do I have a proportional relationship? No, because not all the ratios are equal. It's not, I'm going to write it in here, is not a proportional relationship, okay? You complete it. Because not all the ratios are the same. You have different in the last one. This is that's the way how you have to prove it. You solve each one. The exercise 5, each triangle is equilateral. Is the relationship between the perimeter and the side length of the equilateral triangles proportional? Explain. Okay. Each triangle is equilateral. Is the relationship between the perimeter? What is the perimeter? The sum of the sides, remember? The sum of each side. So for the first triangle, what is the perimeter? 3, right? Because you sum 1 plus 1 plus 1. For the second triangle, you have 2 inches. You are going to sum 2 plus 2 plus 2 because all the sides are equal. And from the for the third one, you need to add 3 plus 3 plus 3. So you have 3, 6, and 9, the perimeter. So we can divide to find if they are equivalent or not. Okay, we can divide 3 over 1, the perimeter, equal 6 over 2, equal 9 over 3. It's going to be a proportional relationship. Yes, because if you divide 3 over 1, you have. Okay, but we can simplify in this. 3 over 1 equal. You simplify this. The half is 3, and the half of 2 is 1. Equal. The third of this is 3, and this is 1. So yes, they are a proportional relationship because all the radius are equal. Okay, number 6. Number 6. Is the relationship between the number of tickets sold and the number of hours proportional? If so, how many tickets were sold in 8 hours? Okay, we are going to solve the exercise complete. We find if they are a proportional relationship. I think they are, because they are asking you to find the number of tickets sold in 8 hours. So probably they are going to be a proportional relationship because they want you to find another value. So, but we are going to try it the same way. Remember, they are asking you the number of tickets sold and the hours. So what is going to be on the numerator? The tickets sold, and you divide 240 over 3, the number of hours, equal 400 divided by 5 hours, and 720 in 9 hours. Okay, we can divide in here. This is 80 if you divide again 400 by 5 is 82, because 5 times 0 is 0 and 5 times 8 is 40, equal. You multiply 9 times 0 is 0 and 9 times 8 is 72. So the simplification of this is 82. So they are a proportional relationship. I just told you at the beginning of the problem because in many cases it's an obvious question. They want you to find a proportional relationship so you can solve later for the value of the other variable. Okay, you are going to use this one, right? Okay. You can use, okay, I'm going to use the 80, but remember we cannot use it alone. 80 has to be divided by 1. 80 tickets sold in 1 hour. 80 tickets sold in 1 hour. So they are asking you how many tickets were sold in 8 hours. So you have 80 in 1 hour, and you need to find how many tickets. We can use any variable. I'm going to use AH to know how many tickets. Or we can use the T to be tickets. I'm going to use T. The variable depends on you, it doesn't matter. T are my number of tickets in 8 hours. Do you understand the relation in here? You relate the radius. 80 tickets in 1 hour, and I want to know how many tickets I'm going to sell in 8 hours. You write the tickets on the numerator and the hours on the denominator. The important part in here is that you relate the quantities in the same position. Okay. Now, the 8 that is dividing my variable need to be passed to the other side to multiply. So I have 80 times 8 divided by 1, but it's not going to affect the 1. Remember, it's not going to affect. This is equal T. And what is the answer of 80 times 8? 8 times 0 is 0, and 8 times 8 is 64. This is the number of tickets they sold in 8 hours. Do you understand what we did? I only passed the 8 to multiply to the other side because I want to have my variable alone. My variable cannot be divided by any number or multiplied by any number. So this number is affecting my variable and pass it to the other side. So D is 640 tickets. And you can prove it. If you add 80 to this one, you are going to obtain the 720 for the 9 tickets. Okay, we have another one, practice and problem solving. The amount of seed a landscaper uses in the area of lawn covered have a proportional relationship. Complete the table. Okay. Seed in ounces, 2, 3, and 4 in the area covered. So you are going to divide the area covered by this number of seed. Look that they give you the example. They write the area covered by the divided by the seed number of seed. You have the first one. You divide 50 of the area covered by the 2 seeds, and you simplify. This is 25 over 1. We can solve the other ones to complete the table. You are going to divide in the number 2, 75 over 3. Yes, 75 over 3. And when you simplify, you obtain again 25 over 1. In the first one, you have 100 over 4. This is only to complete the chart. 100 over 4, and you divide again, you have 25 over 1. So they are a proportional relationship, right? Because in each one, you have the same relationship. You are going to have 25 over 1. Remember, when we work with the radius, we write the number 1 to divide by number. Like in this one, 80 over 1. You write the number 1 to show the fraction, to show the relation. Or the proportion. It really is a proportion, and they are in a relation with the other part. Okay. Number 8, I'm going to help you to understand what's happening here. Construct arguments. Is the relationship between the number of slices of salami in a sandwich and the number of calories proportional? Explain. What are you going to do again? You are going to divide the number of calories by the number of slices of salami. Yes. For example, you divide 66 over 1, 96 over 2, and are they proportional? 96 over 2, it's 48. 66 over 1 is 66. So they are different. Since the very beginning, they are different. 126 divided by 3 is 42. And 156 divided by 4 is 39. They are completely different in each one. You have 66 over 1, 48 over 1, 42 over 1, and 39 over 1. They are completely different. So they are not a proportional relationship. Number 9, and we finish with this one. Look for relationships. I helped you a lot, I think. Remember, you'll send me tomorrow the page 100, 101. We almost finished this one. And you have the 102 with the homework, okay?
Just those pages.
Tell me.
Yeah, just those pages.
100, pages. 101, and 102. And the pages from the last section, right? That was the 94, 95, and 96. Okay. Are the pages from all the week. Now, the number 9, and we finished. Look for relationships. A wholesale club sells X by the dozen. Does the table show a proportional relationship between the number of dozens or of X on the cost? Okay, what are you going to do? Divide the cost by the number of dozen. So, for example, you divide 21 by 6, 28 by 8, 35 by 10 is going to be proportional. 3.5 in here, 28 over 8, 3.5. It's going to be proportional, I think. 49 divided by 14. It's proportional because in all the radius you obtain the same result, right? You obtain the same result, so it's going to be proportional. You can write it on your book. It's proportional. So when you are solving on your free time, on the afternoon, you are going to see that it's proportional, and if you have that it's not, you need to correct the answer and change it. Okay. So see you tomorrow, guys. Have a nice day.
Bye, mister. Have a nice day.
Have a nice weekend. Okay.